more concept. Welcome back again to Growth from the Academy. Don't forget to subscribe. Alright, so this question we are going to answer came in 2025, just last year. Science paper 2, rather chemistry. So let's take a look at the question. It is saying, this is B4. 4 grams of impure iron 3 oxide reacted with 600 cubic centimeters of 0.1 moles per cubic decimeter sulfuric acid. Then it said construct the balanced chemical equation for the reaction. State symbols are not required. They don't even need state symbols. So what's this? When you see cubic centimeters, you should understand that this is volume. When you see mole per cubic decimeter, this is concentration. Very important to know that. Of course, grams, you know that this is mass. So we've been given mass, volume, and concentration. They want us firstly to construct the equation. So we have iron 3 oxide reacting with sulfuric acid. So this is iron 3 oxide. So this is our question A. So iron 3 oxide. This is iron 3 oxide. Okay, yeah, you can watch the previous videos I made on how to construct these chemical formulas. So it is reacting with sulfuric acid. This is sulfuric acid, H2SO4. So these two have reacted to produce what? So you understand that this is iron 2 oxide reacting with sulfuric acid. So we are going to have iron 2 sulfate. That's what will come from the metal and the acid. That's how it goes. So the metal is iron, the acid is sulfuric acid, and it always gets the sulfate. If it's sulfuric acid, the salt will be sulfate. So we are going to have iron 2 sulfate. This and this will react. Then hydrogen and oxygen will also react to form water as the other product. So we are going to have here iron 2 sulfate. So sulfate, it's going to be, iron 3, yeah, it's going to be like this. Plus the other product, this hydrogen will go with this oxygen. It's going to form water, H2O. This is the equation, but it's not balanced. We have 2 ions here, even this side 2 ions here. We have oxygen 3 plus 4, 7. Here 4 times 3. When you write it like this 3 affects everything inside. So 3 is with everything. So you multiply. So this is 4 times 3. So oxygens here are 12 because 4 times 3 is 12. Plus this one 13. So oxygen is not balanced. Okay, we go to hydrogen first. Here 2, here 2. Then we go to sulfur. Here 1. What about here? Sulfur. These 3. So we have 3 sulfurs. Here we have 1. So if we add a 3 here, the sulfurs becomes 3 because this 3 affects everything here. So we have 3 sulfurs. Okay, so sulfur is balanced because here sulfur 3, even here 3. Now because of these 3, it affects the hydrogens. So hydrogen becomes 2 times 3, 6, and here we have only 2. So if we add a 3 here, hydrogen becomes 2 times 3, even this side 6. What about oxygen? Because these 3 again affects even oxygen. So oxygen becomes 4 multiplied by 3, 12, plus these 3 here, 15. What about this side? 4 by 3 is 12, plus these 3, 15. So the equation is balanced. Alright, that's how you go about it. We go to the next. If you have a question, leave it in the comment section. This is more concept. Yeah, I know. So leave the questions in the comment sections. In the comment section, I'll answer them. Question B. Calculate the mass of the pure oxide that reacted with the acid. So they want us to calculate the mass of the pure oxide because understand the question. This iron oxide, the iron oxide is what? Is impure. This mass they've given us, it is for impure. Now they want us to find the mass of this same iron oxide, but not the impure one, the mass for the pure. So more like we have this mixture, okay, or this compound which has this mass, okay, in its impure state. Now they want us to find the mass when it the mass of the pure one. So that's the difference. We have two things. The pure has this mass, the impure has this mass, 4 grams. Now what is the mass of the impure iron 2 iron 3 oxide? All right, so for you to answer this question, you need this equation and you need it balanced. If you fail to balance even these ones, the rest you get them wrong. See here, this is iron oxide they are talking about, iron 3 oxide. So for us to find the mass of this iron 3 oxide, the pure iron 3 oxide, that reacted with what? With the acid. I'm repeating, I answered science, the full paper. You should refer to it. I said, whenever they ask you under more concepts to find something, like in this case, they want us to find the mass, they will always give you what to use. That is always the case. They cannot ask you to find the mass without giving you something to use. So whenever they ask you something, go back to the question and see what have you been given. When you look here, see that we have been given volume and concentration, like I said in the first place. So this volume and concentration are for what? Are for sulfuric acid. Meaning, whenever they are asking us to find the mass of iron, they've been giving us information about sulfuric acid. So they are asking us to find the mass of iron using information of sulfuric acid. So in your calculation, this is B. We are dealing with iron. This is O. Iron 3 oxide. We are calculating the mass of this using sulfuric acid because they've given us the information about sulfuric acid. So it is iron, this one, versus this one. That's the first step. This is very important because for us to find the mass, keep this equation. We are going to use the equation, we'll say number of moles is equal to mass over molar mass. This is one of the common equations under mole concept. So we'll say cross multiply mass by 1, it's mass being equal to number of moles times this molar mass. This is the equation we are going to use. So we need the number of moles of this iron. The molar mass we can find, it's very easy. But we need to find the number of moles. So how are we going to find the number of moles? That's the information they gave you. Firstly, we are going to use to make the mole ratio from the balanced chemical equation. You understand that here, what's the number here? There is no number, meaning the coefficient is 1. Versus, what about here? What's the number here at the front? Or in the front here? It's 3. So sulfuric acid has 3, while iron oxide has 1. This is the mole ratio, 1 to 3. Now the next step, you are going to put your information you've been given here for sulfuric acid. Then for iron, we'll put X so that we can find the number of moles to put here. Now the information, they've not given you the number of moles because this is mole ratio. So here you need to put number of moles, but they've given us volume and concentration. So we need to convert this into the number of moles. How? So you need to understand concentration is equal to number of moles over volume. It has many formulas, but this is one of them. Concentration is equal to number of moles over volume. Since we are looking for number of moles, we'll say over 1, we cross multiply. 1 times N is N. C times V it will be C times V. So number of moles is equal to concentration times volume. So number of moles of sulfuric acid is equal to concentration of sulfuric acid they gave us in the question, 0.100. So 0.100. You see why I said it's important to know what you are given. If you don't know that this is concentration, you will not answer anything. So it's very important to know the SI units. So this is concentration multiplied by volume. Volume we are given, it is 600, but here is the difference. Concentration is in cubic decimeters. Volume is in what? Cubic centimeters. So you have to convert this volume from centimeters to decimeters. It's very simple. 1000 cubic centimeters is equal to 1 decimeter. 1 cubic decimeter. What about 600 cubic centimeters is equal to how many decimeters? X. Then you cross multiply. Of course, this will cancel with this. So we're going to have 1000x when we multiply x times 1000 being equal to 1 times this. We're going to have 600 cubic decimeters. Then over 1000. Even here over 1000. So x is going to be, you have the calculator, this is chemistry. So you simply say 600 divided by 1000. This is 0.6 cubic decimeters. So this is our what? This is our volume. So when we come here, we are looking for number of moles. We said concentration times volume. So volume, that 600, it is the same we've converted into 0.6 cubic decimeters. So number of moles is going to be, now you say 0.100 multiplied by 0.6. This is 0.06 moles. These are the SI units. So this is for sulfuric acid because all this information was given for sulfuric acid. So sulfuric acid is here having 3. So here we are going to put 0.06, the one we've calculated. What about the number of moles for iron? That's the one we are looking for. Then we cross multiply. X times 3, it will be 3x being equal to 1 times 0.06, it is still 0.06. So over 3 over 3. X is going to be, so 0.06 divided by 3, 0.02, 0.02. So these are the moles of what? Of this now, the iron oxide. So since we found the number of moles, it's easy to use this equation I told you, this one now, to find mass. Because I said we're going to say, since they are looking for mass of pure, number of moles times molar mass from this equation. So our mass is going to be, number of moles we've calculated 0.02 times molar mass. We need to find molar mass of what? Iron 3 oxide. Well, it's easy to find the molar mass. You can find it even from here. So we'll say, okay, let's find it from here. So we'll say this is iron 3 oxide. How many oxygens do we have here? 3 here. Multiplied by the mass number of oxygen, it is 16. So then we come here. How many iron do we have here? We have 2. Multiplied by the mass number of iron. So you go to the periodic table, you have it in the exam. So this is the periodic table. Iron is here on the transition metals. See that the mass number is what? 56. So you multiply it by 56 being equal to, so 3 times 46, you have your calculator. 3 multiplied by 46 is, 3 multiplied by 16. 3 multiplied by 16 is 48. Yeah, I was saying the answer. Then we said 2 multiplied by 56. That's 112. Now we can add this 112 plus 48. That's 160 grams per mole. So this is molar mass. So this is the molar mass for what? For iron 3 oxide. So if when we balanced, if it had a 2 here, you have to multiply a 2 here. Very important. Then we come here. Mass of this ion is equal to number of moles. We calculated 0.02 multiplied by the molar mass. We calculated 160. So mass is going to be 160. The answer we calculated multiplied by 0.02. It's giving us 3.2 grams. So this is 3.2 grams of what? Of pure oxide. That's the one they asked about. Okay, that's the one they asked about. And it had only 2 marks. So you need to calculate all these equations for 2 marks. Then, the last question. Calculate the percentage purity of iron 3 oxide, assuming that the impurities did not react with the acid. Now they want us to find percentage purity as our last question. So this is very simple if you've calculated everything well. Percentage purity, this is question C. This is how we write it. Percentage purity is equal to mass of pure substance. In this case, we are talking about iron 2 oxide. So mass of this divided by what? Mass of impure. So this is mass of pure divided by mass of impure sample multiplied by 100%. So this is why it is called percentage purity. It is talking about purity. Mass of pure sample over mass of impure sample multiplied by 100. So our percentage purity is going to be, what is the mass of pure? The one we have from calculating 3.2. So if you got it wrong, everything is wrong. 3.2 grams over mass of impure, the one they gave you in the question, 4.00 grams of impure. So yeah, 4.00 grams of impure. That's the one you use. 4 grams. It is same as 4.00 multiplied by what am I writing? Multiplied by 100%. So you just get your calculate. This gram will cancel with this. So we're going to have 3.2 divided by 4. That's 0.8 multiplied by 100. So 0.8 multiplied by 100. It's giving us 80 as our percentage purity. So 80%. And this was our last question. Yeah, this is the calculation. Couldn't see. So percentage purity is equal to this divided by this, 3.2 by 4, that's 0.8 multiplied by 100, that's 80%. That's it. This is more concept. Don't forget to subscribe for more videos.